let's evaluate line integral over region C, or lines curve C, 4x cubed ds, where C is shown by this graph here. Okay, it starts here, and it's just a horizontal line till we get to -1 there, 0, -1. Then it curves up to +1, and then it goes straight up to y = 2 there. All right, the C1 is just y. C2, I guess there's lots we could do there, but let's call it y = x cubed minus 1. And then, of course, C3 is just a vertical line, so that's x equals a number, in this case, x equals 1. Yep. Okay. All right, so that's our curve. Got many pieces. So what do we do to evaluate this? Well, to evaluate this line integral, we're going to break it up into C1, C2, and C3, right? And add those line integrals all together. So what we need to first do here is parameterize each curve. All right, so C1. I need to write it as x equals this, y equals that. Well, obviously we've got y equals -1. And then the x value, well, the x can be whatever we want it to be, right? But at t, yeah, we're just going to assign the x value to t, and then t goes from -2 to 0, yeah. That'll get all those points right. All right, then C2, well, C2 is y = x cubed minus 1. Remember, to parameterize a function, y equals some function of x, you just let x be the t value again. And then the y is then t cubed minus 1, right? That would give us that curve. And in that case, t ranges from what to what? 0 to 1. And then C3? Well, the x is always 1. So the x is 1. In that case, the y is t. And then t ranges from, well, it would be whatever the y values range from, 0 to 2, right? So yeah, the t values don't necessarily have to be in order there, because in this case, t goes from 0 to 2, t goes from 0 to 1. So, but that would get us each part of that curve. Okay, so now we just do the line integral over each part. So what would the line integral over C1 be? That would be 4x cubed. X is t in this case, so it would be 4t cubed times the square root of dx dt would be 1 squared, plus dy dt would be 0 squared. So what do we get there? Just be 4t cubed, right? Oh, and from -2 to 0. So we've got the integral 4t cubed from -2 to 0. So that's should be t to the 4th, right? -2 to 0. It would be 0 minus 16. -16. Then over C2, 4x cubed ds would be, integral would be, again, x is t, so it would be 4t cubed, times the square root of dx dt would be 1 again, squared, plus dy dt would be 3t squared, dt, and in this case t is ranging from 0 to 1. So there, I think we've got 4t cubed square root of 1 plus 9t to the 4th. Yeah, this is a little harder one, isn't it? Not too bad. How are we going to do that one? Little u substitution? Yeah, little u substitution. U equals 1 plus 9t to the 4th, so du would be 36t cubed dt. So yeah, we just need, say dt is du over 36, and we got it, right? Okay, so yeah, we wind up with 4 square root of u du over 36, so yeah, 1 over 9. Square root of u, so that'd be 2/3 u to the 3/2, which u is 1 plus 9t to the 4th to the 3/2. And we're going from 0 to 1 there. So I believe we wind up with 2/27 10 to the 3/2 minus 1, all right? Plug in 0, you get 1. 1 to the 3/2 is 1. Let's just say minus 2. Okay. All right, so then the integral over C3, 4x cubed ds, that would be, well, in C3, x1 is 1, so that's good. That'll just be 4 times 1 cubed would be my parameterization for 4x cubed, right? And then the integral, the square root dx dt, well, that would be 0. Derivative of the x be 0 with respect to t, and the derivative with respect to is 1. So not much there, and we're going from 0 to 2 on that. That's just 4 dt, isn't it? It'll be 4t from 0 to 2. That's just 8. So yeah, our integral then is sum. Yeah. So our integral for 4x cubed ds over our c, we just take the integral for c1 yeah, you take the integral over each one. 4x cubed over c1 over c2, and then add to that 1 over c3. So we got negative 16 plus 2/27 10 to the 3/2 minus 2/27. That's C2's over C2 region or line, and 8. Yeah. Negative 8 minus 2/27. It's 2/27. Yeah. Yeah, I don't know. Maybe round it off or whatever. Let's see. What would that be? I don't know. I didn't bring my calculator. All right. So, something like that. Yeah, your square root of 10, 10 to the 3 halves is the square root of 10 cubed. So, yeah, you get 10 square root of 10 out of that, yeah. I believe that's something equivalent.